here's our prox detect function. Okay, here's the meat and potatoes here. Our sensor pin is our analog pins I. I is the light string number. Lamp pin, digital pins I. Pin mode, lamp pin, output. So we're setting the output pin mode to output, making sure that that's set to the correct setting. The digital right, lamp pin high. This is turning the LED on. Delay cap charge delay. That's just going to allow it to be on for a second, not a second, but very small fraction of a second. Lamp lit val equals analog read sensor pin. We're reading the cadmium sulfide cell while the light is on. Then, here we're turning the light off. We are going to wait a second. And these delays probably aren't even necessary. Then we're going to read the sensor pin again with it off. And then difference equals diff. That's another function that I wrote that gives us an absolute value. Difference between the dark value and the lit value. And then if the serial debug is on and the MIDI is off, we're going to output some data about what we just did, and we're going to return that difference, which is backscatter. Here's our diff function. Toggle mode. This is the function that changes between chord trigger mode, insane mode, and the other undefined mode, which is really just individual note mode. Activate mood invert. Well, that is a waste of a function right there. Sorry. Flash acknowledge. Okay, this is the cool little function that makes it do its flashy thingy when you change modes. It also does a little beep. All lamps on, self-explanatory, all lamps off. Count strings triggered, pretty simple. It's just counting the ones that are triggered to give us a number. Control combo. This is checking to see if we have done that light string combination that changes modes. Modulation cue. This is, and I know these are named kind of cryptically, but these are similar. This one is looking for that that seventh light string in conjunction with any other light string that will cause the chord's mood to change. And notice it's called 6 because it's actually numbered from 0. So 6 is actually the 7th light string. 0 to 6 is the same as 1 to 7. I know it's kind of confusing, but in C it's normal to 0 index your arrays. Node on. This function used to actually send MIDI data. Now all it does is put a velocity into the MIDI velocities table. And then all of the actual MIDI sending and receiving and stuff is done by the refresh function, the MIDI refresh. Node off, pretty much same thing. Kill all MIDI. This function is no longer used, but basically just turns off all the notes. MIDI all notes off. That's actually a command in MIDI that will kill all the notes, supposedly. Really kill all MIDI. I guess I was having trouble with stuck notes and I was getting desperate. These functions are totally, you can ignore them. MIDI send. Okay, this is the meat and potatoes about how the MIDI works here. Command, pitch, and velocity. Serial print. So the serial print stuff, that's all going to dot through the TX or transmit pin at the data rate that has been specified during setup. So 31250 for MIDI. If it's 9600, you're not going to be getting MIDI. You're going to get weird stuff happening. RC time. You can ignore this. Doesn't use this anymore. That's a digital read function. Flash. This just turns a pin on and then turns it off. I don't know why that's there. Old code probably. Beep. Frequency output with 2000 or 2 kilohertz frequency, and then a delay. That's a lovely function right there. Sound. I think this is an old function. Yeah, old code. Play tone. Old code, I believe. Play notes. Old code. Freak out. There we go. I did not write this function, freak out. This is from arduino.cc. I must give credit where credit is due. It's an awesome function. It works really well for just sending a square wave tone to any given pin. And while it's sending that tone, nothing else is going on. You got to remember that. So unlike with MIDI, you can send a MIDI message, turn a note on, and then you can go back to doing whatever you want to do. And you can multitask that way because some other device is handling actually playing that MIDI note. But with the frequency out here, you are doing this until further notice. As long as that is beeping, you are doing this. So it kind of sucks. Wave out multi. Don't worry about this. This is test code. And then pulse. Oh wow, that's real freaking useful. Ignore that too. So that's the rundown on the Light Harp OS 2.6. There's new stuff in the works for 2.7, but it's not really ready to make its debut. It looks like even with this, I got a lot of junk code to remove. But hopefully, this will help you guys get a head start on this and hopefully help you with your own Light Harp projects. More soon.